This videotape deals with scientific notation, also known as power of 10 notation. One of the main purposes having scientific notation is that it gives us a very simple way to write and to work with very large and very small numbers. For example, let's say we wanted to compute the value 900 million 900 million times 0.000000003. Okay, now many of you would say, well, why in this age of calculators should I bother learning some new way of doing this? I just put this into my calculator. Well, most calculators have an 8-digit display. If you try to put this on your calculator, you'll get as far as, well, you get some of this on. This will come off as 0. The multiplication will come out as 0, which is incorrect. Later on in this videotape, I'll show you how to actually work it out. Now, some calculators have the ability to transform a number immediately into scientific notation. Okay, but regardless, the way to handle very large and very small numbers, especially when both are appearing in the same problem, is to use scientific notation. Now, in order to understand scientific or power of 10 notation, we have to understand the rules of multiplying by 10 and dividing by 10. If you have a number, say 7, and you multiply it by 10, okay, remember 7 is really 7 points. It's always important in this work to keep track of where the decimal point is. 7 is really 7 point, okay, 7.0 and so on. 7 times 10, of course, we all know 7 times 10 is 70. Okay, what has happened is that when you multiply, okay, by 10, you move the decimal one place to the right. Okay, 7 point becomes 70 point. Multiplying by 10 moves the decimal one place to the right. This is really 7 times 10 to the first power. Okay, let's say we're going to divide by. You have 7 and you want to divide by 10. 7 divided by 10. Okay, when you divide by 10, you move the decimal point one place to the left. 7 point becomes 0.7. By the way, dividing by 10 here, 7 divided by 10, is the same thing as 7 times 1 over 10. Okay, instead of dividing by 10, we can multiply by 1 over 10. And I just want to remind you that 1 over 10 is the same as 10 to the minus 1 power. Okay, 10 to the minus 1 power is 1 over 10 to the first power. 10 to the minus 4 power is 1 over 10 to the fourth power. That's how we handle negative exponents. Okay, multiplying by 10, we move the decimal one place to the right. Dividing by 10, we move the decimal one place to the left. Okay, now let's try multiplying by 100. If you have 7 and you multiply it by 100, you move the decimal 2 places to the right. 7 point becomes 700 point. 700. 7 times 100, of course, is 700. You move the decimal 2 places to the right. Okay, I want to put this in power of 10 form. 100, of course, is 10 squared. And if you were going to take 7 and divide it by 100, 7 divided by 100, 7 over 100, that's 0.07. You move the decimal 2 places to the left. To divide by 107, you move it once to the left to get 0.7, twice to get 0.07. Okay, I just want to remind you that 7 divided by 100 is the same as 7 times 1 over 100. Okay, which is 7 times 10 to the minus 2. 10 to the minus 2, of course, is 1 over 10 squared, or 100. Okay, now let's look at what we're doing and see if we can't formulate some kind of general rule here. If you want to multiply a number by a power of 10, okay, if the power, okay, and where the power is an integer, if the power is positive, you move the decimal point that number of places to the right. If the power is negative, you move the decimal point that number of places to the left. For example, when you multiply by 10 to the first, you move the decimal one place to the right. When you multiply by 10 to the minus 1 power, you move the decimal one place to the left. When you multiply by 10 squared, you move the decimal 2 places to the right. When you multiply by 10 to the minus 2, you move the decimal 2 places to the left. And in general, we have the following rule. To multiply a number, okay, by a power of 10, by 10 to the nth power, where n is an integer, if n is positive, you move the decimal point n places to the right. If n is negative, you move the decimal point n places to the left. And if n is 0, which means you're multiplying by 10 to the 0, which of course is 1, you multiply by 1, the number doesn't change. If n equals 0, you leave the decimal point alone. I'll give you a few moments to copy the rule. Okay, let's try out our new rule on some examples here. Okay, in each case, we want to multiply the number 6.3 by a power of 10. Okay, in the first case, we're multiplying by 10 to the first power. Okay, since the power is positive integer here, we're going to move the decimal point that number of places to the right. 6.3 times 10 to the first power is going to be 63. You move the decimal one place to the right. 6.3 becomes 63 point, or just 63. Okay, if you have 6.3 and you multiply by 10 to the second power, you're going to move the decimal 2 places to the right. 6.3 will become, you're moving the decimal 2 places to the right, will become 630 point. Okay, 6.3 decimal 2 places to the right, okay, becomes 630. Okay, if you start with 6.3 and you multiply by 10 cubed, you move the decimal 1, 2, 3 places to the right. So 6.3 times 10 cubed becomes 6,300. Okay, now 6.3 times 10 to the 0. When you multiply by 10 to the 0, 10 to the 0 is just 1. That leaves you with 6.3. There's no change. 6.3 times 10 to the minus 1. Now, in all of these, we're multiplying by 10 to a negative power. When you're multiplying by 10 to a negative integer power, you move the decimal to the left. Okay? 10 to the minus 1, you're multiplying by 10 to the minus 1, you move the decimal one place to the left. 6.3 becomes 0.63. When you multiply by 10 to the minus 2, you move the decimal point 2 places to the left. 6.3 becomes 0.063. And finally here, when you multiply by 10 to the minus third, you started with 6.3. You move the decimal 3 places to the left. You get 0.0063. Okay, now we will say a number is in scientific notation if it's in the form a digit, decimal point, another digit, times 10 to some power, 10 to the nth power. Okay. Now you could develop another rule. There's nothing sacred about this. This is just the conventional way of doing it. In other words, you put one digit to the left of the decimal point, okay, and then say 2 digits to the right. Of course, if it's a whole number, you can say just write 7.00 or just 7, okay, and we'll assume that the digits to the right of the decimal are 0. Okay, now let's practice writing numbers in scientific notation. This is sort of like thinking about the rule that I just gave you for multiplying by a power of 10, but using it sort of in reverse. Okay, I want to write the following in scientific notation. Okay, let's start with the number 4,350. Okay, we're going to write this as 4.35 times 10 to some power. Okay, that's scientific notation. One digit to the left of the decimal. In this case, we have two digits to the right. 4.35 times 10 to some power. The question is, what is the power? Okay, now you say to yourself, this is the number we want, which is 4350 point. Decimal, of course, is to the right of the number there. Now, if you had 4.35, you'd have to move the decimal once, twice, three times to the right to get 4,350. Okay, if we start with 4.35, to get the number that we have here originally, 4,350, you'd have to move the decimal once, twice, three times to the right. If you're going to move the decimal three times to the right, that's the same as multiplying by 10 to the third power. Okay, you can check this out. 4.35 times 10 to the third power. You multiply by 10 to the third power. You move the decimal here three places to the right. Gives you 4,350. Okay, let's try 560,000. We're going to write this in scientific notation as 5.6 or 5.60, it doesn't make a difference, times 10 to some power. We want to figure out that power. Now, if the number had been 5.6, yeah, okay, if you have 5.6 and you want to get 560,000, to go from 5.6 to 560,000, you'd move the decimal 1, 2, 3, 4, 5 places to the right, which is the same as multiplying by 10 to the fifth power. And you should always check your answers here. If you have 5.60, you move the decimal 5 places to the right, you would get 560,000. Okay, now let's look at the number 0.06. We would like to write that in scientific notation. That is going to be 6.00, or just 6, times 10 to some power. We got to figure out what the power is. Okay, if we had 6 and we wanted to get 0.06, in other words, we have the number 6 and we want to get the number 0.06, we'd have to move the decimal once, twice to the left. To move the decimal twice to the left is the same as multiplying by 10 to the minus 2 power. And to check that, we have 6 times 10 to the minus 2. We move the decimal once to the left to get 0.6, twice to get 0.06. Okay, let's try one more problem, 0.000172. Going to write this in scientific notation. We'll write it as 1.72 times 10 to some power. 1.72 would put the decimal here. We really want it over here. We'd have to move it to the left once, 4 times. Moving to the left 4 times is the same as multiplying by 10 to the minus 4 power. You have 1.72 and you move the decimal 4 places to the left, you will get 0.000172. We're now in a position to use scientific notation to help us to compute, calculate arithmetic expressions that involve very large and very small numbers. Let's go back to the one that we started the videotape with. That is 900 million times 0.0000003. And as I mentioned before, most calculators would not be equipped to handle this. Okay, what we're going to do is first rewrite each of these numbers in scientific notation and then make use of what we know about working with exponents. Okay, 900 million can be thought of as 9, or 9.00, times 10 to, let's see, which power? Well, 9.00 is over here. We want to move the decimal once, twice, 3, 4, 5, 6, 7, 8. 8 times to the right. So that's the same as multiplying by 10 to the 8th power. Okay, 900 million is 9 times 10 to the 8th power. Similarly, this horrible-looking decimal over here is really 3.00 times 10 to some power. If we had 3-point decimal over here and we wanted to get this, we'd have to move the decimal once, 2, 3, 4, 5, 6, 7, 8, 9 times to the left. That's the same as multiplying by 10 to the minus 9th power. Okay, now we can simply perform the indicated multiplications. We'll take care of the stuff without exponents first, and then we'll worry about the powers of 10 here. We have 9 times 3 times 10 to the 8th times 10 to the minus 9th power. Okay, well, 9 times 3 is 27. And you know that if you have 10 to the 8th power times 10 to the minus 9th power, we're making use of the rule a to the m times a to the n is a to the m plus n. The base is the same, so when you multiply, you add the powers. 8 and the minus 9 gives you minus 1. 27 times 10 to the minus 1. This is, of course, 27 times 10 to the minus 1. To multiply by 10 to the minus 1, you move the decimal one place to the left, giving a final answer of 2.7. Okay, so you see that the answer of 0 that most calculators would give is not correct, and scientific notation provides us with the correct answer. Okay, let's work out some more complicated examples. Well, say we have 720 times divided by 0.0004. We're going to rewrite the numerator and the denominator in scientific notation. 720 is 7.2 times 10 to the second power. If you had 7.2 and you multiply by 10 to the second power, you move the decimal 2 places to the right, you'd get your 720. And 0.0004 is 4.0, or 4 times 10, let's see, to, if you have 4 point, you want to get 0.0004, you move the decimal once, twice, 3, 4 times to the left. So that's the same as multiplying by 10 to the minus 4 power. Now, once again, we can break this up and handle, okay, the part without exponents separately, and then the part with exponents. 7.2 divided by 4 comes out to be 1.8. You can work that over on the side, or you can do it in your head, fine. 1.8 times 10. Now, a to the m over a to the n is a to the m minus n. That is, when you divide, you're going to subtract the powers. So 10 to the 2 over 10 to the minus 4 is 10 to the 2 minus a minus 4. 2 minus a minus 4 is 2 plus 4, or 6. So you get 1.8 times 10 to the 6th. You can leave your answer in this form, or if you want to write it without power of 10, 1.8 times 10 to the 6th means 1, and instead of having the decimal there, we're going to move it 6 places to the right. $1,800,000. 1.8, you move the decimal 1, 2, 3, 4, 5, 6 places to the right. How about 6,000 times 0.00008 over 0.003 times 40,000. Once again, we will rewrite each of these numbers in scientific notation. By the way, if you want to try this on your own, you can shut off the videotape machine and come back after you've finished the problem. Okay, 6,000 is 6 point times 10 to the third power. Multiplying by 10 to the third power, you move the decimal 3 places to the right. 0.000008 is 8 times 10 to, let's see, now if the decimal were here, we'd have to move it back 1, 2, 3, 4, 5, 6 places to the left. So we have 8 times 10 to the minus 6. 0.003 is 3 times 10 to, let's see, if you had the decimal here, you move it 1, 2, 3 places to the left. And finally, 40,000 is 4 times 10 to, let's see, we move the decimal 1, 2, 3, 4 places to the right. Okay. On the top, we have 6 times 8, okay, times 10 to the 3 times 10 to the minus 6. Rewriting the numbers without exponents first, and then on the bottom, 3 times 4, 10 to the minus 3 times 10 to the 4th. Okay, 3 goes into 6 twice, 4 goes into 8 twice. Okay, these of course are ones. What we've done is divide numerator and denominator by 3 here, leaving 2 and 1. Divide numerator and denominator by 4, leaving 2 and 1. So we have on top 4 and on the bottom 1. Now on the top we have 10 to the 3 times 10 to the minus 6, which is 10 to the minus 3 power. Okay, you multiply, you add the powers. 10 to the 3 times 10 to the minus 6 is 10 to the 3 minus 6, 3 and minus 6, which is minus 3. 10 to the minus 3 times 10 to the 4 is 10 to the minus 3 plus 4, or 10 to the first power. And then finally, four over 1, or 4 times now 10 to the minus 3 over 10 to the 1. When you divide, you subtract the exponents, you get 10 to the minus 3 minus 1, or 4 times 10 to the minus 4 power. And if you want to write this, okay, without power of 10 as a decimal, 4 point times 10 to the minus 4, you'd move the decimal point 4 places to the left, giving you 0.0004. You started with 4 point, you move the decimal 1, 2, 3, 4 places to the left. 640 times 0.08 divided by 16,000 times 0.002. Okay, 640 is 6.4 times 10 squared. 0.08 is 8 point times 10 to the minus 2. Here you're going to move the decimal 2 places to the left to get the 0.08. Here 2 places to the right to get the 640. $16,000 can be rewritten as 1.6 times 10 to the 1, 2, 3, 4 power. And finally, 0.002 is 2 point times 10 to the 1, 2, 3 minus 3 power. Okay, we have 6.4 times 8 over 1.6 times 2. Okay, times, now here we have 10 squared times 10 to the minus 2 here 10 to the 4th times 10 to the minus 3. Okay, 2 into 8 goes 4 times. Okay, 6.4 over 1.6 is the same as 64 over 16, which gives us also 4. Of course, you can go over to the side and actually work this out. 1.6 into 6.4. You'll get the answer, 4. Here we have 4 times 4 over 1 times 1, that is 16, times. Now 10 to the 2 times 10 to the minus 2 is, of course, 10 to the 0. 2n minus 2 is 0. 10 to the 4 times 10 to the minus 3 is 10 to the 1. In both cases, I added the powers because we were multiplying. And now, since we are dividing, okay, 10 to the 0 divided by 10 to the 1, 10 to the 0 divided by 10 to the 1 is 10 to the 0 minus 1. We subtract. You get 16 times 10 to the minus 1. Okay, you can leave it like that, or, well, 16 point times 10 to the minus 1. Multiplying by 10 to the minus 1, we move the decimal one place to the left, giving us a final answer of 1.6. And that brings us to the end of this tape.